Welcome to my slidecast presentation on the 3D printing process. In this project, I will walk you through how 3D printing works, the technologies involved, materials used, applications, and post-processing techniques. This slidecast aims to provide a structured and easy to follow guide for beginners. 3D printing, also known as additive manufacturing, is a revolutionary technology that allows objects to be built layer by layer from a digital model. Unlike traditional subtractive manufacturing, which removes material from a block, 3D printing only uses the material necessary to build the object. This has made it widely popular in industries like medicine, where custom prosthetics are created, and in aerospace, where lightweight but strong components are designed. There are several types of 3D printing technologies, each with its own advantages. FDM is the most common and affordable method used for rapid prototyping and hobbyist projects. SLA is known for its high precision and is used for applications like jewelry and dental implants. SLS, on the other hand, allows for strong, industrial-grade prints using powdered materials, making it ideal for aerospace and automotive industries. The 3D printing process begins with designing a model using CAD software. Once the model is finalized, it is sliced into thin layers using slicing software, which generates the toolpath for the printer. The object is then printed layer by layer, and once finished, it undergoes post-processing to remove imperfections and improve its final appearance. The material used in 3D printing depends on the desired strength, flexibility, and appearance of the final product. PLA is beginner-friendly and biodegradable, making it great for prototypes. ABS is more durable and is commonly used in engineering. Resin prints allow for high detail applications, while metal 3D printing is used in advanced industries like aerospace and healthcare. 3D printing has a wide range of applications. In medicine, it is used to create patient-specific implants and prosthetics. The aerospace industry benefits from lightweight yet strong components that reduce fuel consumption. Meanwhile, manufacturers use 3D printing for custom product development, reducing production time and costs. After printing, additional post-processing techniques are applied to enhance the final look and functionality of the object. This can include removing support structures, sanding rough edges, or even painting and coating the model for a professional finish. To wrap up, 3D printing is more than just an emerging technology. It's a revolutionary force reshaping industries. From healthcare to aerospace, this process enables innovation by allowing for rapid prototyping, custom designs, As advancements continue, we can expect 3D printing to become even more accessible, cost affordable, and integrated into everyday applications. Understanding its structured workflow from design to post processing gives us a clear vision of its vast potential. The future of 3D printing is limitless, and its impact on technology and society will only continue to grow. Here are some reliable sources where you can explore more about 3D printing technologies, materials, and real world applications. These references provide a deeper understanding of additive manufacturing and its growing impact across industries. Thank you for watching. I appreciate your time and hope this helped you understand 3D printing better. Feel free to reach out with any questions. Keep exploring and innovating.